This is the 7th lecture in our review before we start off some Algebra I material, and today we're going to talk about prime and composite numbers. It's kind of a switch in gears from what we were studying before with computations with decimals and estimation and so forth. So let's talk about what it means to be prime and composite. It has to deal with divisibility. That's a big word, divisibility. And what this means is whether or not a number divides into another number, or finding factors of numbers. So let's, for example, 6. Let's find all the numbers that are divisible by 6. So we know 1 divides into 6. 1 times 6 is 6. And 2 times 3 is 6. So 2 is divisible by 6. And then we would go on, but we would repeat this side backwards, so we can stop once we get to this side. So the 4 factors of 6 are 1, 2, 3, and 6. How about 12? Okay. 1 and times 12 is 12. And 2, is there a number that multiplies by 2 to get 12? And that is, yes, 6. And then 3 times 4 is 6. So the factors of 6, again, we can stop because 4 would just be the same thing on the reverse side. The factors of 12 are 1, 2, 3, 4, 6, and 12. Let's try one more. How about 15? 1 times 15 is 15. 15 is not divisible by 2, but 3 times 5 is 15, and 4 does not divide into 15 evenly, and then we would be back to 5. So the factors of 15 are 1, 3, 5, and 15. Now, let's look at a special number here. How about 7? And why is 7 special? Well, 1 times 7 is 7, but there isn't a number time that you multiply 2 by to get 7, or 3. 3 times something isn't 7. 4 times a number isn't 7. 5 times the number isn't 7. And 6 times the whole number isn't 7. So the only factors of 1 are 1 and 7. So 7 is a special number called a prime number. And a prime number has only factors 1 and itself. The only factors of a prime number are 1 and itself. These numbers are different. They're special. They're the opposite. They have other factors than 1 in itself. Those are called composite numbers. Composite numbers have factors other than 1 and itself. Okay, so before we determine how to figure out by divisibility test whether a number is prime or composite, let's find all the prime numbers under 100. Okay. So what I have here is a chart of all the numbers less than 100. And 1 is special. I'm going to put a box around 1 because 1 is what we call 1 is neither prime nor composite. And the same can be said about 0. 0 is neither prime nor composite. It's just the way it's defined. So we go to the right and we get the first prime number, 2. So from there, we can cross off all the multiples of 2. So that's 4, 6, 8, 10, 12. In fact, everything in this row is going to be crossed off, so we'll just do the quick way here, because if I keep multiplying by 2s, I'm going to get to this row. I'm also going to get to this row. So just to save time, all the even numbers are multiples of 2. So these are not prime. So I'm going to cross them out. So those are all what's left to the right is the next prime number, which is 3. So now we're going to cross off the multiples of 3, and we're just going to go 3, 6, 9, 12, 15. Every third number I'm going to cross off. 18, 21, 24, 27, 30, 33, 36, 39, 1, 2, 42, 1, 2, every third number you cross off. 54, 57, and 57 and 3 is 60, and 60 and 3 is 63, 66, 69, 72. I'm just counting by 3, 75. And I'm doing it rather quickly because I think we can all add by 3 here. All I'm doing is adding by 3 and crossing off numbers. 87, 90, 93, 96, 99. Okay, so the next number I circle to the right will be prime. So the right of 3, the next one that's not crossed off is 5. And that's the easiest one to count the multiples of. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. And now the next number that's not crossed off will be the next prime number, which is 7. Now most of these numbers are already crossed off. I think there's 2 that are not. But let's count by touchdowns, like points of 7. 7, 14, 21, 28, 35, 42, 49 is not prime, it's 7 squared. 56, 63, 70, 77, I haven't got to yet. 77, and then is 84, 91, 98. Okay, now we're on to 11 is the next prime number. And I think most of these are there. And the 11s are actually diagonal right here. 11, 22, 33, 44, 55, 66, 77, 88, 99. Those are already crossed off. The next prime number is 13. I do not think, I think that everything left is going to be prime here, but I'm not sure. 13, 26, 39, 39 and 3 is 52, 52 and 3 is 65, 65 and 3 is 78, 78 and 3 is 91. Okay, and that's that. And I think that's all the prime numbers less than 100 are what's left. 17, 34, yeah, 19's prime. Okay, so we'll just circle what's left. Once you get to a certain point, 37, 41, 43, 47 is prime, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Okay, so let's write these down. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. And dot, dot, dot. These are the prime numbers less than 100. So it's these numbers that we want to check against first. The first couple of these. There's tricks for divisibility through 11 that I'm going to teach you. And after that, you just have to pretty much divide by hand. Hopefully that you have a number that's divisible by 2, 3, 5, 7, or 11. And in most standard tests, they're going to give you the number, if they say, is this prime or composite? Most likely they're going to give you a number that is divisible by these. So what we're going to do is learn divisibility tests that test against 2, 3, 5, 7, and 11. And 7 is a little bit tricky, but it's not too hard to learn. So let's learn some of these divisibility tricks. to determine whether a number is prime or composite. Divisibility. Divisibility. That's a big word. Tricks. Okay, so the first prime number is 2. And a number is divisible by 2 if it ends in an even number. 0, 2, 4, 6, or 8. So 58 is not going to be prime. It's going to be composite because it's divisible by 2. Let's look at the next prime number is 3. 3 is a little bit more trickier. The sum, that means add the sum of the digits is a multiple of 3. For example, 21 is divisible by 3 because if you add up the digits, 2 plus 1 is 3. And 3 is divisible by 3, so 21 is divisible by 3. 153, if you add up those digits, you get 1 plus 5 is 6, and 6 plus 3 is 9. So 1 plus 5 plus 3 is 9. 9 is divisible by 3, so this is divisible by 3. Let's see, how about 314? Is 314 divisible by 3? 3 plus 1 is 4, and 4 plus 4 is 8. 8 is not divisible by 3. So this is not divisible by 3. Okay, let's do the next trick, the last of the easy ones. 5 is the easiest one. If it ends in 0, which we've already tested whether it's prime or not, or 5. So if it ends in 0 or 5, 55, 175, 2,325, those are not going to be prime because they're divisible by 5. So let's look at the next prime number, 7. Now this is where it gets a little trickier to learn these tricks. 7. So the number we're going to look at to test 7 is 203. Okay, so we're going to take the last digit. Take the last digit and double it. Subtract from what's left. If the number is divisible by 7, if the result is is divisible by 7, the number is. Okay, so that sounds a little tricky. We're going to test 203. So I'm going to take the last digit, and double it. So the last digit is 3. If I double the last digit, I get 6. Now I subtract. 20 minus 6 is 14. 14 is divisible by 7. So 203 is divisible by 7. Let's prove it. And 7 goes into 20 twice. And it works. Okay. Take the last digit and double it. Let's do 98. I think this only works on 3-digit. Yeah, this is only going to work on 3-digit numbers or bigger. So the only 2-digit number that you have to worry about is 91 and 49. Those are divisible by 7. If you remember 91 and 49. But anything bigger than that, you're going to have to use the trick. Let's see. How about, I think 112 is divisible by 7. Let me see. 98 and 7 is 105. Yeah, 112 is divisible by 7. Okay, so if we take the last digit and double it, we get 4. And 11 minus 4 is 7, so it works. Okay. 105 is divisible by 7. Take the last number in multiply last digit and double it, last digit and double it, and you get 10. 10 minus 10 is 0, and 0 is a multiple of 7. It's 0 times 7. So it counts with 0. Okay, so that trick's a little bit tougher. but it's doable if you practice. All right, let's do 11. 11 is the last trick we're going to learn. And you split the digits into alternating pairs. Add their and find their sums. If the difference is a multiple of 11, the number is. Now I know that's a little hard to take in from that definition, but I'll show you some examples. One that we already know, I think. Oh wait, I don't know if 333. Let's see. Let's just find a multiple. 33 times 11, right, is 33, and 33, that's 363. Okay, so we're going to test if 363 is a multiple of 11. Okay, so I take this, every other number. So I'm going to take these two and make a number, and this, and I want to put this one down like that. So if we add these two up, we get 6. We add the outside, we get 6. And we add the inside, we get 6. 6 minus 6 is 0. 0 is a multiple of 11, therefore this is a multiple of 11. How about some bigger numbers? I think I got some bigger ones here we can test. 968. This is one that doesn't really look like a multiple of 11, but it is. 968. So here we're going to add up every other digit. 9 plus 8 is 17, and then the middle sum is 6. So 17 minus 6 is 11, and 11 is a multiple of 11. So 968 is a multiple of 11. Let's look at a 4-digit number just so we can see the bigger picture here. Let's multiply 343 times 11. Okay. So 343, that sum is 3773. I think you can already see how this is going to work out. Okay, so we add up this pair, and we get 10. And we add up this pair, and we get 10. And 10 minus 10 is 0. So this is a multiple of 11. All right, let's test some of these numbers and see if we get a prime number or a composite number. And some of these are easier than shown because they are most of these that I have here are, you can just look at them and tell. So let's try 373. 373. All right, it's not even. This might be a prime number. 373 is, and you have to go to the square root. Okay, and the square root of 400 is 20, so you have to test to at least 19. Okay, 19 would tell you whether or not it's prime or not. Okay, so 373 is not divisible by 3 because the digits add up to be 13. 3 plus 7 is 10, and 3 more is 13. So we tested 2, it didn't work. Tested 3, it didn't work. Tested 5, it doesn't end in 5, so it doesn't work. 7, okay, so we're going to double this and get 6. And 37 minus 6 is 31. And 31 is not a multiple of 7, so it's not 7. Let's check out 11. If we add these digits, we get 6. 7 minus 6 is 1, so it's not a multiple of 11. Now after that, we have to start dividing longhand. So 13 divided by 373. Okay, let's test this out. All right. 13 goes into 37 twice with the remainder of 11, and 113 goes in 9 times, 8 times. Okay, and that's a 4 and 104. There's a remainder. It doesn't matter what it is, so it's not divisible by 13. The next, we got two more to test. Let's test 17. I can already tell you by looking at it, it's not going to be a multiple of 17. But don't ask me how my magic brain works like that. This one's prime, I'm pretty sure. 17 times goes into 37 twice. 34, remainder 3, and 33 goes in once, remainder 16. So that's not going to work. 17's got a remainder. Let's test 19 just to be thorough. I already know that it's not a multiple of 19. And why do I know that? Because 19 times 9 is not 373. If you could think about that. But all right, 19 goes into this once, and that's 19, and remainder's 18, and 183 is 9. But there's a remainder. So it's prime. Go to the square root. The next prime number is 23. 23 squared is more than 373. So 373 is prime. Let me try to find one that is not prime. That is pretty big here. Let's see. About 255. That one would be easy. Is 255 prime or composite? 255. Doesn't matter. Ends in 5, so you already know off the bat it's not. It's prime. We'll try this one here. $221. That's a good one. That's a good example. Is 221 prime or composite? I think you could tell by the fact that it took me a while to calculate that it's going to be composite. But don't take my word for it. Let's figure it out. It's not even. So it can't be a multiple of 2. The next prime number is 3. And you add up the digits and you get 5. Not divisible by 3. Doesn't end in 5, so it's not 5. 221, if I double this, I get 2, and I subtract that and get 20. 20 is not a multiple of 7, so 7 is not going to work. 11. 3 minus 2, look, 3 is the outer digits, minus 2 is 1. 1 is not a multiple of 11, so it's not going to work. Alright, I think you're onto my ruse here. 13 goes into 22 once. And we're going to multiply that out to be 13, and we get 91. And 91 goes into 13 7 times. So 21 is 13 times 17. So 221 is composite. The best way to determine whether a number is prime or composite, in most of the examples they're going to give you, they're going to be divisibles of 2, 3, or 5. But there are very small cases, maybe on the SAT in the future, where they give you something like 91 that is divisible by 7, or 221 that's 13 times 7, or maybe 13 times 11. That's another popular one. Let's see, what's 13 times 11? Just so we can test it. 143. That's a popular one. That's a big number. This number is composite, and it tests all the way up to 11. All the other ones will fail. It's not even, so it's not divisible by 2. Let's check our 2. Add up the digits. You get 8, right? 7, 4 and 3 is 7, and 1 more is 8, so it's not divisible by 3. Doesn't end in 5. Double 3, you get 6. Subtract that, you get 8. 8's not a multiple of 7, so it's not going to work. But 4 is the outer sum. Minus 4 is 0. So it is divisible by 11. So 143 is composite. All right, that's going to do for the lecture on prime and composite digits. The next digit, we're going to actually go in and factor these using the same thing. We're going to find prime factorizations, and we will see you then. Thank you for watching.